Welcome to Chemical Bonds. There are 6 types of chemical bonding: covalent, ionic, metallic, dipole-dipole, hydrogen, and London dispersion bonds. They're all the things that keep everything in balance. There are many different ways to tell if an element will make an ionic, covalent, or metallic bond. For me, the easiest way is by looking at what type of metal it is, or what type of element it is. An ionic would consist of a metal or a nonmetal. A metal would be a positive cation, a metal or ammonium, or a positive or a... There are many different ways. There are many different ways to tell if an element will make... There are many different ways to tell if an element will make an ionic, covalent, or metallic bond. For me, the easiest way is by what type of element it is. For ionic bonds, you start with a positive cation, or a metal, or ammonium, and you have a negative anion, a metal. Your valence electrons are transferred. So when you think of ionic, think of transferred. It's different for covalent. When judging what type of bond an element will form, for covalent, you have 2 nonmetals. They normally create molecules, and they're shared. And then with metallic, it's a metal and a metal, and with these, your valence electrons are they're moving within the metal, so moving. And those are the easiest way to tell what type of bond an element will make. Alright. Now we're going to go over the properties of ionic, covalent, and metallic bonds. Now we're going to start with ionic. Ionic bonds have a high boiling point, a high melting point, and are usually solid at room temperature. They're malleable. They're conductors in water. And they're very hard. Yeah, the properties of covalent bonds. Covalent bonds normally have a low melting point, a low boiling point, usually gas at room temperature, and if solid, they're very hard and produce. Metallic properties have a high boiling point, a high melting point. They're solid at room temperature, they're good conductors, and they're malleable. Most or all metallic compounds or bonds share similar qualities and traits as metals. Naming ionic compounds. First, you start with your cation. If it's a transition metal, tin or lead, use a Roman numeral. You have your anion second. If it's a monoatomic element, change the ending to "-ide". If polyatomic, copy from chart on back of your reference table. We're going to start with Fe2O3. First, we're going to write iron 3 because there are 3 oxygens for every 2 irons. And then for a second word, our anion, we're going to write oxide because on the second word, you always add "-ide". And you end up getting iron 3 oxide. See? For a second example, we're going to start with sodium and chlorine. Step is to write your first element, which comes first, your cation, sodium. And then you write your second one with "-ide" at the end. So it would be sodium chloride. Same thing. For naming covalent bonds, you use prefixes to denote the number of atoms in the formula. You change the ending of the second word to "-ide, and you do not use mono if there's one of the first element. Your prefixes include 1 is mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 is nona, and 10 is deca. We have CO2. When naming this covalent bond, you do not put monocarbon for the carbon. You put carbon. And for the second element, you put dioxide because there are 2 oxygens. You end up with carbon dioxide as your final. For a second example, we're going to have 2 nitrogens and 3 oxygens. When writing this, because you have 2 nitrogens, you write dinitrogen. And because you have 3 oxygens, you write trioxide. So you get the name of dinitrogen trioxide. Now we're going to talk about intermolecular bonds, or van der Waals forces. It's bonding between separate molecules. It's weaker than ionic or covalent. First, we're going to start with hydrogen bonding. Hydrogen bonds are the strongest intermolecular bond. They form between the hydrogen of one molecule and the nitrogen, oxygen, or fluorine of a neighboring molecule. Next, you have dipole-dipole. They're slightly positive and negative poles created by a polar covalent bond. The slightly positive pole of one molecule is attracted to the slightly negative pole of a neighboring molecule. It is the middle strongest. It's not the weakest, but it's not the strongest. We have dispersion forces, also known as London dispersion. It is the weakest bond, and it is most important between nonpolar molecules. Thank you for watching. I hope you enjoyed this bonding tutorial. Our script is brought to you by Brandon Holton, and it's voiced over by Ileana Centeno.